Hi, we're here answering Astronomy Exam 1 practice. So astronomers still use constellations as regions of the celestial sphere to denote general locations of stars and objects. When we look at an object that's 1,000 light years away, we see it not as it is now, but as it was 1,000 years ago. The declination of the sun on the first day of spring, well, sun is crossing the celestial equator on the equinoxes, so its declination is 0 degrees. A little math problem in number 4. 8 divided by 2 is 4, and then we have 10 to the 5th divided by 10 to the minus 3 becomes 10 to the plus 8, so the answer is D, 4 times 10 to the 8th. With the constellation there, we want to know the declination, which is on the vertical axis of Alnitak, which is the southernmost star here. And we see that is about minus 2 degrees. Moving on to the next page, which one of the following statements about circumpolar stars is true at all latitudes? They rise in the east and set in the west, not necessarily, but they do always remain above your horizon. The angle between the celestial equator and the ecliptic is due to what? Let's see, that's the 23.5 degrees tilt of the Earth's axis, which shows where the star A will be in 12 hours. Well, 12 is half of 24, so that means it's gone halfway around a circle in the sky, and that would take it to position D. On the first day of winter, the sun rises on its farthest south of east for the entire year. You observe Bellatrix on your meridian at 10. Will be 30 days later. It's going to be 4 minutes earlier every day. 4 times 30 is 120, which is 2 hours, so you'd have to be out there at 8 p.m. to see it. Taurus is visible on winter evenings, but not summer evenings because of the location of the Earth in its orbit. When it's winter in the northern hemisphere is tilted away from the sun, and we don't see any answers here, so please skip that question. How are wavelength, frequency, and energy related for photons of light? Longer wavelength is going to mean lower frequency and lower energy. Answer A. From longest wavelength to shortest, which of the following correctly orders the different categories of electromagnetic radiation? From longest to shortest. We know radio are the longest, gamma rays the shortest, so the answer is C. Betelgeuse is a bright red star. Which is true? Which would infer from its red color? Its surface is cooler than the sun. Yes, it's much brighter. No. So the answer is A. It's cooler surface. A star's luminosity is the total amount of light that the star radiates each second. Shown to the right are the black body curves of 3 stars. Consider the following. Which of the statements are correct? The 7,000 appears bluish white is correct. The 577 emits more light per second than the 4,000. That's correct because the curve is higher, has more area underneath it. And the 4,000 emits more infrared than that. That is not correct. So the correct statements are 1 and 2 only. Choice D. When the atom absorbs a photon containing energy, any of the following can happen except which? It can become excited, it can become ionized, it has to move to a larger orbit. So C is not something that can happen. The spectrum of the sun shows a series of dark absorption lines of hydrogen superimposed on a continuous spectrum of light. What can you draw from this observation? That cooler hydrogen must overlie the hot surface to produce the absorption lines. Which of the following statements best describes the 2 principal advantages of telescopes? We know that telescopes will gather more light and will give you better angular resolution. D. How much more light will be collected by a telescope equipped with a 5 meter than with a 1 meter? We know it goes as the diameter squared, so it'd be 5 to 1 squared, or 25 times. Department store sells an astronomical telescope with an objective lens of 200, diameter 8, and an eyepiece, focal length 10. The magnification is the focal length of the objective over the focal length of the eyepiece, so that's 200 over 10, or 20 times. Which of the following persons reorganized the spectral classification? We know that was Annie Jump-Cannon. Okay, we have a parallax of 5 seconds of arc. The distance is 1 over the parallax, so 1 over 5 is 0.2 parsecs for the distance. Which of these statements about the stellar spectral types OB, AF, G, M are true? They are in order from hottest to coolest. That's about all we can say. Answer A. For which of the following wavelengths emitted by stars are there Earth-based observatories? We know that only radio invisible telescopes are built on Earth for that reason. The distance to a nearby star can be measured by measuring the apparent change in its position with respect to other more distant stars over a period of 6 months. The color of a star, when combined with the thermal radiation curve, tells us which of the following. It tells us the temperature of a star. Shown to the right is apparent. This will not be on the exam because we have not covered binaries yet. So please skip questions 20 and 30. Now we move on to true and false. The larger the apparent magnitude, the brighter the star. That is going to be false. We know it's dimmer. Just the contrary, it should be dimmer. Standard incandescent light bulbs produce emission spectra. False. They produce continuous spectra. Radio waves move slower through space than X-rays. That's false. They move at the same speed, the speed of light. A telescope able to resolve 2 arcseconds is better than one to resolve 1 arcsecond. That is false. The smaller the angle, the better the resolution. And in seeing, poor seeing means the atmosphere is turbulent. That is true. Short answer. Determine which is sense or nonsense. The constellation Gemini didn't exist when my grandfather was a child. Well, unless your grandfather is hundreds of thousands years old, this is nonsense. And the reason is the stars don't move that rapidly across the sky. If you look through a diffraction grating at the light reflecting off a blue sweater, you'd find the entire rainbow. That is nonsense, because we know that the blue sweater will only reflect blue light. Because of the higher frequency, X-rays must travel faster. We already know that's nonsense. All light travels at the speed of light. Sirius looks brighter than Alpha Centauri, but Alpha Centauri is closer because its parent shows a star. That is indeed true. So that makes sense. A red dwarf in a cluster will have a much longer lifetime. We haven't touched upon this yet, so please skip that question. Okay. Shown to the right is an energy level diagram. How much energy is emitted in the photon for the transition from the 3 to the 2 state? Well, we have to take 3.4 and subtract 1.51 from it. So that would be 3.4 minus 1.51. and that's going to give us about 1.89, I believe. And the energy units for electron volts. What would happen if an atom in the ground state absorbed 15? Well, it would go from minus 13.6 way up here, and so it would be ionized. It would be ionized. And lastly, would we expect helium to have the same energy levels? No. Why? Because helium has 2 protons and 2 electrons, and so the orbits will be different than those for hydrogen. Now we have an HR diagram. We'd like to know what named star is the hottest. Hottest stars are to the left. So we look and we see Sirius B will be the hottest. Which named star is the largest? Well, for that we look over to the right because we know the supergiants are there. And we see that we would have probably something like Betelgeuse would be the largest. Why is it larger than Rigel? Because it's cooler than Rigel and almost the same luminosity. So Betelgeuse. Which star is larger, Vega or Pollux? Well, Vega is here, Pollux is here again on the same horizontal line. They have the same luminosity, so the cooler star has to be larger. So the answer to C is going to be Pollux. And approximately how many times more luminous is Regulus than the Sun? We have to read the vertical axis. The Sun, of course, is 1. Regulus looks like it's at about 10 to the second, so we can put an answer here of 10 to the second or 100 times brighter or more luminous, I should say. Okay, going on to the next question. We have 2 stars. Mishka is an A3b and Baru is an M2I. Which star is bigger? Well, we know that the luminosity class 1 stars are going to be the supergiants, so Baru is going to be the bigger one. Which one is more luminous? Well, luminous will also be measured by the luminosity class, and that will also be Baru. Which is hotter? Mishka is an A3. That tells us it's hotter than an M2. So the answer is Mishka. And I've tried to explain the answers as we go. Okay, complete the diagram. This is a concept map. You want to show connections between things. So for example, stars is what we're dealing with. Telescopic and instrument observations give us absorption spectra. That's already given there. And we know that the absorption spectrum, or absorption spectra, tells us F, the chemical composition of things. All right, so let's go on the other side. Unaided eye observations of stars. Well, the key is unaided eye. That means we see constellations. G. Okay, now let's see. What helps us find distance? Well, that we found was parallax. So we would put a D in here for parallax. Now let's see, classified by, how did we classify stars? We classified them by luminosity, yes, and by temperature. So over here we'll put answer A for temperature. And luminosity and temperature, when we plot them, we know that leads to the HR diagram.